Okay, we're actually training. The accuracy is pretty low. It's not getting any higher. And the loss function is pretty high, which is not good as well. Okay, so we're developing this website that has interactive web applications primarily around biomedical data, but...
That sounds really interesting. Are you looking for specific features or functionalities to include in these applications?
Can you be less obvious, more critical, more funny, and bring back the accent that I asked for? You seem to have forgotten about it.
Ah, got it. So, developing a website with interactive apps around biomedical data, eh? Sounds like a blast. What's the plan? Make it super serious or add a sprinkle of fun in there?
Well, what do you think the fun versus serious ratio should be?
It's a delicate balance, you know? Maybe lean a bit more on the serious side, but keep some fun elements to keep things engaging. What do you think?
Yeah, that sounds good. Can you help me with that?
Absolutely. We can start by highlighting the serious content and then sprinkle in some fun interactive features. How does that sound?
Sounds great.
Perfect. Let's strike that balance and make it awesome. What should we focus on first?
Let's see.
Take your time. When you're ready, we can dive into the details.
We actually have a list of things we need to fix.
Great. What's at the top of the list? Let's tackle it step by step.
What's alphabetical order? Is it? No, it's not.
No worries. Alphabetical order or not, what's the first item you want to tackle?
We're doing we have actually 2 chatbots, but yeah, there's some issues with both of them.
Got it. What kind of issues are you seeing with the chatbots?
One of them is loading forever.
The never-ending load.
Yeah, the never-ending loading, that's right. And it's actually run it locally.
Running it locally is a good call. Helps narrow down if it's a server issue or something else. How's it behaving locally?
No, so it's meant to be trained. We're training locally, but then the deployment is just HTML and JavaScript.
Gotcha. So the chatbot's trained locally, but the deployment's pure HTML and JavaScript. Could be a client-side issue then. Maybe some JavaScript hiccup?
Okay, give me a sec. Let me load it in another Visual Studio Code window, and we're using Copilot for doing the actual coding, if you don't mind.
That's a solid setup. Using Copilot can definitely speed things up. Are you seeing any errors or warnings in the console?
No, I'm not seeing any warnings yet. Give me a sec. Yeah, it took ages to load, so we'll need instructions for the bot to fix that. I think the general problem is that it's like a multimodal. I mean, it's a language. It's just a chatbot, but it's doing a couple of things. It's doing from memory. It's doing both NLP.
So it's multitasking with NLP and memory functions. That can slow things down. We might need to optimize how it's fetching and processing data. Have we tried profiling the performance?
Okay, we can try that. Let's just open Copilot.
Sure thing. Let's get Copilot open and see what we can tweak.
Let's do the code base.
All right, diving into the code base. Where should we start looking first?
Okay, we're starting with 4.0. Okay, can you quickly test can you quickly explain the files?
Sure. The for loop iterates through elements, so check for inefficiencies or
Okay, we'll have to turn that.
Sorry, I can't assist with that.
But you should load the 35 references from code base. No, what's the code base? Yeah, what do we have in the edit? No, forget about that. Yeah, we have the Chatbot.js. Model.js. Okay, can you explain the current project? The quick response, text only, don't include any code?
The project is a web-based chatbot application called BioniChaos Assistant designed to answer questions about biomedical tools and resources. It integrates TensorFlow.js for AI-based responses, uses a JavaScript chatbot implementation, and includes a user interface for interacting with the assistant.
Okay, so essentially it's a pre-trained chatbot, is that correct?
Yes, that's correct. The chatbot likely uses a pre-trained model or a custom-trained model loaded via TensorFlow.js to handle user queries about biomedical tools and resources.
Okay, let's do the tree. Can you try and explain the project file structure? Which files being called by the HTML? The HTML meant to be calling Chatbot.js and Chatbot.js is calling Model.js. Can you explain those quickly? Why do you think the page is loading for quite some time? What do you think the bottleneck might be?
Possible bottlenecks causing slow page load. Data fetching. The chatbot fetches two JSON files, BioniChaos_data.json and improved_training_data.json.
So did you say that we are processing the model when the page loads? I thought that should be done offline on the server.
The model should be pre-trained offline on the server and only the trained model weights should be loaded into the browser for inference.
Now, can you tell me why is this? How do we change it? Do we need to change it so it actually generates the JSON, like the model weights, so we can load them on the front end? Okay, so the thing is currently, yeah, it's not acceptable because it's loading forever. Okay, so can you write clear instructions as to how we improve, consolidate the files, remove unnecessary files, and do all the training offline, so we get the JSON weights for the model, and then it's just being loaded in the front end, so everything is working much quicker, and making sure the model is still giving correct responses. Yeah, but it's like okay, so modifying the workflow, training offline, and then there are questions: should we run it from scratch? So scrape the website again, then we're converting the model to TensorFlow.js. I don't understand. Can step 3, the convert the model to TensorFlow.js, be done in Python itself? Why do we need to do it separately? Yeah, we need to modify model.js. Okay, so model.js again. So we're loading the pre-trained model. It shouldn't be compiling. I think before it was compiling a model when the page was loading. Okay, we need to get the folder correctly. Okay, so we're loading the pre-trained weights. It's actually putting limits at trouble loading. That's because of the libraries. Okay, the model JSON is obviously not there, suggesting compressing the data. We have the scraper, we have the model.js folder. One of the trained models writing into that folder. Do a tree quickly. We have 11 files. I'm not sure how long this scraping takes. We won't do it right now because we already have it. Okay, so currently I have this file and folder structure. What am I missing? It should say the train model, the weights.
You need the model.json and group 1 shard 1 of 1.bin file.
We prepared the training data. If we get the readme for a sec, then we need to train the model. We're getting an error. We're getting an error when training. Of course we do. I thought we do have TensorFlow. Can you do text only? Don't include any code. Can you explain this in conversational language, what the problem might be?
The error indicates that the x_train array, which is being created from the QA_pairs data, has inconsistent shapes for its elements. This happens because in code_text.
Okay, I don't actually quite trust it. Let's give this train model to a better model, and it is important, so give it straight to 3.7 Sonnet thinking model. Give it the same output, and this is a coding. This might be coding straight away, maybe. It's actually editing. Oh, yeah, it's actually said the same thing as GPT-4o, so it's patching the vocabulary size, reshaping Y-train to be compatible with sparse categorical cross entropy when using sequence data. Okay, we can pretend to understand what it did, but we're doing vibe coding, so we're just gonna accept. We'll eventually know if the chatbot is working or not. Okay, we're actually training. The accuracy is pretty low. This thing, it's not getting any higher. And the loss function is pretty high, which is not good as well. Oh, come on. Didn't have the... Hey, can you explain in conversational language what's going on? It did start training. It couldn't actually save the file, but also, hey, can you make comments on the accuracy and the loss? What might be the issue there? And it seems like it wasn't able to actually save the model, or was the model not created properly, or did we have a conversion issue?
Good news. Your model has successfully trained. There are two main points to discuss: the model saving error and the training performance. What's going on? Training progress. The training completed all 10 epochs successfully. That's great. Model saving error. The error is straightforward. Newer versions of Keras require specific file extensions when saving models. The training accuracy reached 55% and validation accuracy stuck at 54%. The training loss decreased. Good. But validation loss started increasing after initially decreasing. This pattern suggests early signs of overfitting. The model is memorizing the training data but not generalizing well to new questions.
And now I expect it, 4, 8, 5, 6. Nah, it's not doing great. Error dumping weights. Let's actually move to 3 mini. It's a reasoning model, but it should be much faster as well. Okay, can you explain what's happening there? We do have now the model.js folder generated, but it's empty. There is a model.keras file in the static folder. I don't know why. I don't think it should be there. So we had an error as well. And if you can comment on why the model accuracy is pretty low, and comment on the loss as well. What's the loss doing over time? So what's 10 epochs? It's obviously will make sense to train for longer.
The training accuracy is hovering around 55% while the validation accuracy is stuck near 54%. This indicates that the model isn't learning robust patterns from the data. The loss decreases during the early part of training and then plateaus, suggesting the model may be underfitting or that the architecture is too simple for the complexity of your data. In short, the saving issue is due to incompatible weight names for TF-JS conversion, and the modest accuracy and loss behavior hint at a need for a more sophisticated model or additional data/regularization to improve performance.
Yeah, we can try scraping the site again. So we obviously talking about the BioniChaos.com. If you haven't checked it out already, please go do so, and don't forget to provide your feedback. So we are scraping all the information on this site. We're doing that locally and training a chatbot. And considering last time we did it quite some time ago, we might do the scraping again. Yes, the model is empty. Right, the model generated is 9 megabytes. Okay, that should be manageable, shouldn't it? It's interesting considering the original data it's actually training on is only it's only around 1 megabyte. So maybe. And yeah, and from the accuracy, it's having trouble to generalize. I can actually try and explain how is that happening. That actually doing anything? No. Hey, should we scrape again? Hey, can we actually review these 4 files? Give me a text-based response, don't include any code, and make it conversational. I want any specific issues found relevant to the previous discussion, and the fact that the model accuracy is pretty low. It's like sitting at 50% and the loss is not going down when training. So can you give instructions as to how the code can be improved?
Here's a summary based on our review of the 4 files. The web scraper, scrape_BioniChaos.py, is extracting tool data reasonably well, but consider checking if the text that becomes questions and answers is rich enough. If the data has a lot of short or imprecise descriptions, the resulting QA pairs may not be informative, which can hurt training quality. The content processor, content_processor.py, does a good job cleaning and organizing data, but you might improve how topics are extracted. It may help to refine the domain terms or tweak the regex patterns for more precise matches. If the content isn't parsed accurately, your training dataset might include noisy or misclassified information. The training data preparation, prepare_training_data.py, converts processed content into QA pairs and builds the vocabulary. One improvement is to experiment with different text pre-processing steps, for example, using stemming, lemmatization, or even pre-trained embeddings, so that your vocabulary captures more semantic meaning. Also, increasing stopword handling or more sophisticated tokenization might help in building a better representation. In train_model.py, the model is a simple LSTM-based sequence-to-sequence setup. The steady accuracy around 55% and plateauing loss suggest the model architecture might be too simple or the training data might not be very informative. Here are some suggestions. Try using a more advanced architecture, e.g., a transformer-based model or adding attention mechanisms, to better capture long-range dependencies. Increase the training data size and ensure the QA pairs are high quality. Experiment with hyperparameters like learning rate, dropout, or the size/number of LSTM layers. Consider integrating pre-trained embeddings, like glove, to provide richer word representations. Overall, improving data quality and enhancing model complexity should help the model learn more robust patterns.
Okay, that's interesting. Let's do 3.7 Sonnet Thinking. We had the best luck with that one. Okay, so we have all the files, including what we scraped, and I'm focusing on the Python files. How can we improve the Python files? So the content processing, the scraping, the preparing, the training data, and actually training the model, so we have better performance than what shown above. If you can explain text-based continuous text, conversational language as well, and start fixing the code.
Step-by-step solution. Create a robust scraping script to extract website content. Improve the content processing to better organize information. Enhance the training data preparation with advanced text processing. Fix the model training script to handle conversational language and avoid errors. Scrape_BioniChaos.py. Create a scraper that fetches and processes website content. Import requests. Import JSON. Import logging. From BS4 import beautiful soup.
How hard do you think it is to train the new chatbot?
Training a new chatbot can be quite complex. It involves designing the right algorithms, collecting and pre-processing data, and iterating on the model to improve performance. The difficulty really depends on the complexity of the tasks you want the chatbot to handle.
So it will be essentially a chatbot for a specific website we are working on. Hey, can you actually look it up? It's called BioniChaos.com. It's bionic and chaos.com with one C between the bionic and chaos.
BioniChaos is a platform offering interactive biomedical data tools and resources. Their website, BioniChaos.com, features various tools across neurological, cardiovascular, and other biomedical fields.
What's on the front page? Can you select the second best, most favorite tool on the front landing page? On the landing page,
I can't interact with or directly view live websites, but typically on BioniChaos, you'd find tools related to various biomedical fields. You might want to check the website directly for the specific tools available.
It's hopeless that way. Let's actually try a Gemini. You can share your screen. Okay, what do you see on the screen?
I see a web page titled BioniChaos with a list of tools on the left-hand side of the page. The tools include Hearing Aid Simulator, PaperViz, PDF Extractor, Procedural, Myoscope, SpectroWave, Boyd's Flocking, Mandelbrot Set, and PendleDraw. There are also navigation links for Home, About, and Contact on the top right-hand side. Is there anything else you would like me to describe?
Yeah, keep going. What do you see now?
Okay, now I see more tools on the same web page. They include biomedical fields visualization, Jazz, Hexball, Myomock, Wolf, Sheep and Cabbage Puzzle, 3D Lego Builder, Dopamine, and Glassfill. Is there anything specific you would like me to focus on?
Okay, keep going and tell me which one's your favorite.
Okay, I see a few more tools, including ChatGPT Author, Breast MNIST, Webcam Filters, Essential Biomedical Tools for Learning and Research, EMG Hand Simulation Tool, Interactive Venn Diagram of AI Types, Datasaurus Dozen Visualization, Seizure Zone, Interactive 3D Brain Mapping Visualizer, and Mental Health Engineering. As an AI, I do not have preferences, so I don't have a favorite tool from this list. Is there any tool here you would like me to describe further?
No, just keep going over the tools. I keep scrolling down the page. Tell me what's unique about the tools that you heard, that we went over so far. And yes, just make a guess. Guess which one will be, the most favorite, most successful tool.
Okay, I've scrolled down the page and see the following tools: Bridging Engineering in Clinical Language with AI, Ponzo Illusion, Joint Time Frequency Scattering for Seizure Detection, Catapult, Pulsaviz, Heart Rate Visualization, Hearing Test, and Graphit Knowledge Graph Visualizer. It seems that many of these tools are related to medical visualization or research, with some interactive or game-like elements. Based on this, and if I had to make a guess, I would say essential biomedical tools for learning and research would be the most successful due to its broad range of applications. Is there any other tool you would like me to describe or discuss?
Yeah, keep going down the list. I scroll down the page.
Okay, I've scrolled down the page further and see the following tools: Cochlear Simulator, Eye Tracker, Real-Time Speech Visualizer, EEG Music, Cardiobot, Rhythm Scan, Vision Impairment Simulator, Event-Related Potentials, ERPs, Advancing Neurotechnology, The Impact and Ethics of AI-Enhanced Brain-Computer Interfaces, and IEEG Review 16-Chan. Many of these seem related to brain activity or sensory input. Is there a specific tool that you would like to explore?
Okay, we keep going down the list, but also so far, which one stands out for you and why?
Okay, I see more tools now, including EEG spectrogram, ethical concerns of neural implants, IEEG spectrum visualization, 100 years of EEG, celebrating a century of EEG and its future potential, IEEG spectrum visualization with wavelet denoising, IEEG impedance, and synthetic EEG signal generator. Based on the tools we've discussed, I would say that 100 years of EEG stands out to me. This is because it appears to be a comprehensive overview that speaks to the history and potential of a large field, while the other tools seem to focus on more specific aspects of that field. What do you think?
No, that's a blog. Can you actually guess which ones are active web applications? The one you selected is a blog. So yeah, ideally we don't place blogs on the website. We have something more interactive.
You are right. I apologize for that. 100 Years of EEG is indeed a blog, while most of the other tools are web applications. If we are looking for active web applications, I would say that the synthetic EEG signal generator stands out because it could be used for experimentation with various algorithms, devices, or theories, making it more interactive and useful. Would you agree?
Sure. Can we just keep going down the list? What else? What else do you see, and which one's your favorite so far?
Okay, I see the following tools now: EEG monitoring in ICU, the diagnostic limits and potentials of EEG, a critical review, EEG cross-coherence function, EEG data visualization, CardioQuest ECG scoring game, ECG synthetic signal generator, and ECG waveform feature extractor. Given that I am an AI and cannot have preferences, I do not have a favorite, but it seems that CardioQuest ECG scoring game is the most game-like tool and could be engaging for a user. Would you be interested in learning more about it?
Which one did you choose?
Since I do not have personal preferences, I did not choose a tool as a favorite. I only suggested CardioQuest ECG scoring game as a tool that might be more engaging for a user. Did you have one in mind?
I like your choice. We actually did you say the CardioQuest? Because we have another one that is actually where you can actually play against that an AI, the Cardiobot, as opposed to CardioQuest. In Cardiobot, you can play an AI.
You're absolutely right, my apologies. I got the names mixed up. You chose CardioQuest, and the tool where you can play against the AI is Cardiobot. Is there anything else you would like to discuss regarding the Cardiobot tool?
Sounds like you want to wind up this conversation.
Yes, it does seem like we've reached the end of our exploration of the tools on this webpage. I am ready to conclude the conversation if you are.
No, there is more, actually.
You are right. There are still more tools listed on the webpage. I see EEG monitoring in ICU, the diagnostic limits and potentials of EEG, a critical review, EEG cross-coherence function, EEG data visualization, CardioQuest ECG scoring game, ECG synthetic signal generator, and ECG waveform feature extractor. Do you want to go over any more tools from this list?
I scrolled a bit further. Are you happy to keep going? Yeah. I had a feeling it will time out, but it say yes, something went wrong. It didn't actually say time out or anything. It just went static emojis into the code for a train pipeline script. It sounds really good. Generating code like Claude is definitely not the laziest out of all robots. I suspect it's doing too much as well. It seems like there is a problem in the train model Python file. It's I think you haven't finished generating it. Can you also explain? Can you continue? Can you fix it? Make sure it's complete, and also explain it in continuous text, conversational text.
Let me fix that and provide a complete explanation. Import JSON. Import NumPy as NP. Import TensorFlow as T.
Yes, and here in the train pipeline. Yeah, it's doing the scraping again. So might let it run. It might take some time. And then we see how the training went. Might have an issue. Can we interrupt? Can you give an overview of what these files are doing? Conversational text, and also fix any issues. There is a linting error in the content processor Py code. Can you quickly check all the Python files and tell me if I just run the train pipeline Python code and expect it to complete the training and save the models in the correct folders, and also can I expect the training to be accurate enough? I didn't actually read that bit. Keep in mind that the training accuracy depends on the quality of your generated training data and the chosen hyperparameters. Give me more details on the last sentence on the training accuracy and the hyperparameters.
The overall training accuracy will depend significantly on factors like training data quality, the variability in your QA pairs, and the alignment between your vocabulary and source texts. The hyperparameters, such as a 10-epoch training scheme, a batch size of 32, and a learning rate of 0.001, are reasonable starting points that help prevent overfitting, with dropout layers and early stopping added to the mix.
Okay, so we scraped this site. Didn't produce a valid model. What? Hey, can you just explain this in conversational text without modifying the code?
It looks like while the training step ran and produced a trained model, the pipeline didn't find the expected TensorFlow.js model file.
Surprisingly, the chatbot is working. How do I replace a radiologist using this website? It's actually working pretty well. Hey, can you give me a specific example of a biomedical imaging tool? Does this response make any sense? Found 39 relevant tools. Okay, it's not working that great. Yeah, it's not answering the questions directly. So that's not great. You might have to continue this next door. Don't forget to check out the website, and we'll continue training chatbots and improving a hearing aid tool. Let me know if you have any special requests. This could be clickable stuff. Yeah, it's weird. It's giving links from the website, okay? Separately, yeah, we have this paper visualization as well. This is all dynamic. You can load your text of your paper. It will give you statistics on the paper, word count pages. authors, blah blah blah, affiliations, Venn diagram for the topics. But the most useful I find to be this research knowledge graph. It will be breaking it down based on colors, structure, method, analysis, finding. Yeah, it's weird, this makes sense. And condition. So the methods use diffusion, MRI, and the structure. Okay. Analysis, tractography, structured tensor. Okay. Research timeline. So this was what was done, and topic distribution. So it's talking anatomy was mentioned this many times. Then we have imaging methods, analysis methods. So yeah, in theory, you could just place your text, paper text in this window, but yeah, the couple papers I tried it with only really works with this one. I'm showing you the abstract. Now I think we have this PDF extractor, which is, again, you can load any PDF, and it will separate the text and the images. You can download them separately if you like, or zip of all the images and download the text as a text file, and it gives you a text preview. How good is that? You could check it out as well. And we're still working on the hearing aid simulator. We just released a video showcasing how it is working so far. There's a reason why it's called a simulator, so don't use it as a hearing aid. Well, yeah, it's not quite there yet. And there's quite a few tools on EMG that we added to the site. You can change a few parameters, baseline noise, flex intensity. You can disable auto scaling. Some people don't like auto scaling. And flex with your mouse in this case, because we had another similar tool that's actually using your mouse. So it's using the touch screen or mouse to simulate. Again, it's a simulator. It's not real EMG, but it's indirectly measuring EMG of your finger, because currently I'm moving the mouse. You can see it's moving on the screen. And the EMG is being simulated accordingly to the movement. It's actually quite nice because it's working also outside the canvas. And you can change the static muscle contraction as your baseline, essentially. Go check it out as well. Yeah, I'll leave you with the simulator. I'll see you later. Bye.